Students are using large language models to write their papers. In response, universities are buying algorithmic software to catch them. Higher education is currently locked in an arms race between machines generating text and machines trying to spot it. This diagram shows the mathematical flaw in that containment strategy. When run through typical AI detection tools, student submissions are evaluated with about an 88% accuracy rate. That leaves a 12% error margin. Scaled across a university processing tens of thousands of assignments, that small margin translates into hundreds of false academic misconduct accusations. Because the software cannot be trusted to definitively prove authorship, traditional assessment formats are breaking down. A standard take-home essay is entirely exposed to tools that can generate a plausible, well-structured response in seconds. Relying on automated surveillance also damages the learning environment. When institutions prioritize policing over pedagogy, classrooms turn into environments of suspicion, where students feel they must prove their innocence to an algorithm. Since detection tools cannot reliably distinguish human and machine contributions, educators are looking at ways to grade the specific evidence of a student's reasoning. Rather than trying to build an AI-proof assignment, which usually involves forcing students to write with pen and paper in a locked room, educators are designing AI-resilient assessments. These tasks accept the presence of generative tools and incorporate them directly into the workflow. Under this model, a student's final deliverable is no longer a single polished piece of text. Instead, they submit a process portfolio. This is a comprehensive record documenting the steps they took to arrive at their conclusions. Students provide their prompt histories alongside an editor's memo. In that memo, they explain exactly why they accepted a specific piece of AI-generated feedback and why they rejected another. Their editorial choices become entirely visible to the instructor. This forces students to practice disciplined skepticism. They run bias audits on the AI's initial drafts to see whose perspectives are missing, and they map out where the machine's claims contradict primary source documents. A student's grade now depends on the quality of their intervention, the documented moments where they verified a claim, corrected a bias, or asserted their own voice. Grading these dense process portfolios at scale requires an updated workflow for educators, too. This flowchart maps out a human-in-the-loop, or HITL, assessment model, which uses AI to assist rather than replace the teacher. In the initial phase, an AI inference engine performs a preliminary pass. It checks the submission against a basic grading rubric and flags any specific assignments that show outlier patterns or receive a low algorithmic confidence score. That's when the human educator steps in to review the flagged work. The instructor manually adjusts the scores to account for things the machine misses, like complex rhetorical devices, cultural nuance, or unconventional problem solving. This chart tracks the results of implementing a human-in-the-loop system. The average time a faculty member spent grading an essay dropped from 12.6 to 7.5 minutes, while 74% of students reported high satisfaction and trust in the fairness of the dual-layered feedback. The machine handles the repetitive processing of raw data, clearing the way for the human educator to apply their ethical oversight, professional judgment, and empathy. Establishing new assessment standards at an institutional level requires coordinated faculty development and deep policy reform. Universities are confronting a difficult reality. Generative algorithms can instantly produce well-structured summaries of existing information. Relying on those summaries to prove a student's competence no longer works. Moving forward, institutions must evaluate the skills that software struggles to replicate. That means testing a student's capacity for contextual reasoning, their ability to navigate complex ethical trade-offs, and their skill at defending original arguments in real time. Resilient educational systems treat the presence of AI as a baseline, concentrating on the original intellectual work that happens after the machine provides its initial response. Genuine academic integrity happens when students and educators stop treating artificial intelligence as a threat to be dodged and start working transparently alongside it to push the limits of their own critical thinking.